All right, everybody. Well, we're going to start our second kind of major unit here, which is on eating per se. Eating, as Chapter 10 describes, and you'll want to kind of use Chapter 10 in writing up some extra information here. Eating is a very complicated situation. This is an intro to physiological psychology. We're not going to learn all the details, and I don't think you need to. Your book in Chapter 10 goes into gory details as far as the nature of eating and what goes on physiologically. A lot of people want to understand this. What I would ask you to do is kind of use the chart I have and some of the simple summaries. You can use that. You can add a little onto it if you wish. That's fine. And if you want to go all the way, you certainly can, but that will not be mandatory here. So starting with the outline, we begin with the idea of metabolism, kind of the nature of eating. What happens biologically when the eating process takes place? And you should use the I tried to find a good chart for you as well. They were all actually way too complicated, so I tried to find an easy one or two. But let's start off with this idea of the set point idea, that your body tries to maintain exactly what it needs in order to function properly. And that's the idea of having enough glucose to use when you're doing activities and enough to save it when you don't, so that when you need to use it again, you will, so that your body kind of maintains a set point for glucose. So we start with the simplest phase that I'll call the absorption phase, which is happening, as the agenda says, when you wake up hungry in the morning. So the first thing you need to know is, if you follow the chart up there, you have a high amount of blood glucose when you eat food in the morning. That actually prompts the pancreas to release insulin. And I'm going to try to make this real simple for us. Insulin does two very important things. The first thing insulin does is insulin allows the glucose that comes in to go right into the tissue cells. It actually allows into tissue cells and neurons. The insulin allows the glucose to be taken up by the cells for what I call immediate energy. So it'll be used for immediate energy. Insulin allows glucose to be taken up and used for immediate energy in the tissue cells. That'll, of course, lower the blood glucose. If there is more glucose than that, which many times there is, what that'll end up doing is that glucose will go into the liver, and the liver will take the glucose and convert it into a kind of intermediary store of glycogen. Glycogen is used as an intermediate store, so if you got exactly enough, it'll be used for immediate energy. The short-term store is as glycogen. And then if you actually have even more glucose than that, too much for the tissues, too much for the kind of intermediate store, then it'll be converted into fat tissue, which is certainly a problem in today's society. So you kind of got three sources where when you do the absorption, it can actually work from. So that is the absorption phase. Now, the other issue is what happens when you are fasting, when you are not eating. The first thing you need to know is energy will first be used from the tissue cells, once again, if you have it there, but usually there's some there, and you can use it right from the immediate store. But then, if you're really in a fasting phase, there might not be so much there, and in that case, the more short-term store, glycogen. Glycogen will be converted back to glucose through the secretion of glucagon. How many G's do we have to have here? Glucagon is like insulin. It's a hormone secreted by the pancreas, and it's secreted during this fasting phase. So if you don't have enough glucose in your cells being used, glycogen will be converted back to glucose in the liver, and that can be used as immediate or as energy once again. So you get energy from the immediate glucose that's in the tissues. If that's not enough, then you'll get energy from the glycogen that's converted into glucose by glucagon. Then finally, if you're still needing energy for the here and now, the fat tissue can be converted into glucose through a couple of processes as well. So that's kind of the metabolism in a very simple way. And obviously, as you might know, if you're doing long distance exercise like I used to do, used to have people eat a lot of carbs, because carbs produce a lot of glycogen. And glycogen is very good if you're taking a long bike ride or doing an endurance activity. During the actual activity, that glycogen will be turned back into glucose by glucagon, and then you'll be able to use that energy in a pretty simple way. So those are the steps of kind of the set point idea with metabolism per se. So hopefully that makes sense. Thanks.